Hi, everyone, and welcome to GLF Live. We're here today for a very important discussion, which is about the tipping point of the Amazon rainforest, one of the most important biomes in the world. A tipping point, in case you need some background information, is a point that, if crossed, leads to irreversible changes in an ecosystem. It's often compared to a tower of Jenga, with things like global warming and degradation being the pieces pulled out from the bottom of the tower and placed on top until the tower tips and falls. So there are tipping points for Arctic glaciers, for the Gulf Stream, and many other ecosystems. But today we're discussing the tipping point of the Amazon rainforest, which means the point at which it will stop generating its own rainfall and dry out into a grassland-like ecosystem. So as the Amazon is one of the largest carbon sinks in the world, this would have major impacts not only on the Amazon and the people who live there, but also the climate and global warming and other ecosystems worldwide. And we are dangerously close to this tipping point, which is why it's crucial that we're here having this conversation today. We're also really privileged because we have with us here one of the foremost scientists who has warned us of just how close we are to this tipping point. Her name is Luciana Gatti, and she was the lead author of a report released in July that perhaps crossed many of the headlines that fill your inboxes. And it was about how the Amazon is releasing more carbon than it captures. She's a senior researcher at Brazil's National Institute for Space Research, and she coordinates one of their labs focused on greenhouse gases. She also sits on the UN Science Panel for the Amazon, and she's generally just one of the most renowned experts on emissions in the Amazon. So Luciana, thank you so much for joining us, and we're so lucky to hear from you. Welcome.
Thank you, Gabrielle. It's my pleasure to be here and have the opportunity to share our findings in the research recently published. Thank you very much.
Of course, it's such a privilege. So we will just dive right in to the main point here, which is how close are we to the tipping point? 17% of the Amazon has already been deforested, and combined with climate change and forest fires, scientific models project that the Amazon will begin to dry out when deforestation reaches 20 to 25%. So we're really close. But could you tell us how close we are and if and when you think we will reach this tipping point?
We need to think in Amazon, not just thinking entire Amazon. It's like we have many Amazons, many forests inside the Amazon, and many regions are in a very different condition because it is 17%. They are considering the whole, but some regions is much more deforested and the others less deforested. When we look, for example, the east of the Amazon, for example, Pará and the north of Mato Grosso state, in our study, we are talking about around 2 million kilometers square of region. This is around 27% deforested until December 2018. This is very important to highlight. Our study was until December 2018, where in the last 50 years, Amazon was deforested, this 17%, but in Brazil, it was also 17%, but in the last 3 years, the last year, the number is not coming, but in the mean, the last 2 years was 1.5% deforestation per year. And then we can imagine very soon we have a number that will complete in 3 years, almost 5% deforestation. In 50 years, 17, and then in 3 years, more 5%. This is an amazing increase in deforestation. What's the consequence in this in these actions when we observed clearly a change in the climatic conditions of forest? This is a very important question that I don't know answer now. What I can say is that we found until December 2018, this region in the east that corresponds around 2 million kilometers square, 27% deforested mean emitted 10 times more carbon than the west part, 11% deforested. Why? This is the most important question we made to ourselves. Why? Why was not proportional? Because usually we think, we make the account, how much was deforested, we look at the area that was burned and put a number, This kind of methods find much less emission than we found measuring CO2 directly in the air. Our project was based in CO2 and CO measured in the atmosphere using aircraft to make these vertical profiles. It's like we measure one column of air, in fact, it's many layers, many heights, starting 4.4 kilometer high until near surface. We have many altitudes where we know the concentrations, and we also know the concentration that air mass enter in the continent. This difference represents what was the contribution from the surface. And then we calculate how many days we found the flux. We measure this to time per month. And then we integrate the year. We found the balance for the year. And studying 4 regions, we found 4 different scenarios. In the west part, that was less deforested, is more similar, but in the east, the northeast was the biggest carbon emission, southeast the second biggest. And our question was, why? What have the different from this region in Amazon for they have this so different behavior? First, we suspect the climatic conditions. Then we calculated pressure, temperature for each region. During the same 9 years, we have the study. We calculated the water available in the soil. We calculated the area burned in for each region, and how much green was the leaves, for each region. This is per month, because to study flux, we calculate per month, and we see the seasonality, where the uptake happens more during wet season, when you have lots of water availability, the temperature is lower. This is the part of the year where the major part of the uptake happens, and during dry season, the major part of the emissions happens. And only the fire emissions was very correlated. Then we can understand very easily the fire emissions, but the other part, what happens in the forest, we didn't understand very well. And then we made the question, what changed in each part of the Amazon? Then we calculate how much was deforested, each region of influence for these 4 studied areas. And also we study 40 years precipitation and temperature in each regions. And then everything makes sense. Northeast, that is the biggest emission, is also the biggest deforestation. This region is 37% deforested. We are talking about 20% the tipping point. This region is 37% deforested. Until December 2018, I just arrived from there 10 days ago, and then now is much, much more, near Flona Tapajós. You observe it a green soybean, ocean. Oh, sorry, orange, orange or yellow, ocean is blend of soybean. It's a nightmare, they are deforesting, deforesting, deforesting. I believe now is more than 40%. And this explains why is the biggest carbon emission, and also explain the big impact in the precipitation. The annual accumulated precipitation there until December 2018 was less 90% precipitation, but the biggest impact in the whole Amazon is during dry season, August, September, October. And this is make a really difference for forest. If you rain more or less during wet season, don't make too much difference for forest because they are not below stress. But in dry season, they are below stress. Then changes in dry season impact extremely the forest functions. In this region, they lose it 34% precipitation during August, September, October. 34. This is extremely high. And the temperature increasing during these 3 months, 1.9 degree. This is extremely higher when we compare the world mean increase in temperature. When included, we sink in the glaciers, in the north part where the increase in temperature is bigger. When you sink in global mean, it's not the same increase in the whole regions. It's less in the equatorial region and is more in the poles. When you go to the poles, the increase is higher. How can we find this increase in temperature in Amazon? It's during dry season, but the trees are there. How they can survive in this, and for example, in this region, they are during 4 months with precipitation below 50 milliliters of water during 4 months. The dry season there is 5 months now. How can big trees, the typical trees from tropical rainforest, survive in this so stressful condition? When we look at the southeast, is the second highest emission, is the second highest deforestation, is to 88%. Also above tipping point. When we look at the temperature increase is 2.5 degrees. But the worst time is August to September. The increase in the last 40 years is 3.1 degree. This is nightmare. How can trees survive, a so big stress? And then when you look at the study from Adriana Esquivel, for example, she make a mortality map in Amazon. In this region, the mortality is 2-3 times higher than other parts of the Amazon. Then we need to analyze Amazon, not an entire body, but some regions are in much worse conditions. And now one question we done that is very important is why Northeast, that is more deforested, are in better condition than the Southeast. Luciano, how you say that is better? Because you told you here, the emission is higher. Okay, let me explain. When we look just at the total carbon flux, we can separate in our study how much comes from fire emissions and how much is the rest. What is the rest? The rest is everything that happens in forest. The absorption is by photosynthesis, and the emission is by respiration and decomposition. Respiration is by the part above ground, below ground, and the decomposition, all decomposition. Then let's imagine a tree starting dry season, and then the leaves start to be less green. you know, what happens when the leaves are less green, start to be more yellow, brown, you know, the photosynthesis reduced, but respiration continues. And then you have imbalance. When you look, you have more emission than absorption this time. And the dry season continue each time worse, you know, more stress to the trees. And then many leaves can fall. And then you stop photosynthesis and continue respiration. And you start decomposition. And some species more sensitive to this stress can die, you know. And then this explains why we observe in the southeast part of the Amazon that now the forest itself are more emitting carbon than absorption. This is not a reality for the whole basin. In the whole basin, the forest itself absorb, you know, remove from the atmosphere 130 million tons of carbon per year. You know, this is the mean for the pan-Amazon. But emissions from deforestation and fire emissions represent 3 times more this absorption. Then the forest itself can reduce 1/3 of the emission we produce to the atmosphere. You know, but in the southeast, when you look at the total flux, 2/3 coming from deforestation and fire, and 1/3 come from the forest itself. And then this means the forests are more dying now than growing. This say we are in emergence in this part of, this is around 1.7 million kilometers square. You know, this say we are in emergency now in this region because, you know, we are losing a big amount of forest, first by deforestation. They deforested, they waited 3 months until they put fire. But during this time, the forest that was not deforested is also dry, very dry, because this region are very dry and very hot. The biggest or the strongest correlation with fire is temperature. You know, is how warm are the temperature and how the leaves are less green. You know, this is the strongest correlation that make the forest more flammable. And then the people put fire in the deforested area or in pasture. That is the main human activities there. And the forest that was not deforested will burn together, you know. And these are not in the account in many modelings, but they will burn. This represents instantaneous CO2 emission. But later, this is the composition, because the burned part will decompose along the time. Another studies show that considering 30 years, you know, the regrow will represent only 1/3 of the total emissions. Then you have in the balance emission from this region, and also the region that was not deforested, was not burned. Some trees are dying, you know, from these stressful conditions. We observed that there are much more feedbacks, you know, from the human activities than is included in the modeling. And this explains why, you know, that when we look at the east part, that is 27% the forest compared with the 12, the carbon emission is not 3 times more, it's 10 times more, because there are, you know, this loop where one goes making consequence in the other, you know. because the trees contributed to the precipitation. The trees evapotranspirating, and the forest itself, the trees represent around 1/3 of the recycling of water to produce the precipitation. If we deforested 20%, nearly, we're reducing 20% this recycling, this recycling in this 1/3 from evapotranspiration. And during the evapotranspiration, you reduce the temperature. If we have 20% less this process, we are also reducing this increase in temperature. Then the temperature also is higher. This is the deforestation, impact, direct impact. But we also have the global climate change that are promoting more precipitation in the northwest part and the less in the southeast part. Then in southeast, we have a two process happen. The global climate change, putting more precipitation there, less here, and here also the deforestation. And this is why this is the biggest water vapor deficit in Amazon that's promoting this big increase in temperature. And in this study, Adriana Esquivel found that the strongest correlation with mortality is the maximum temperature. In our study, we studied the monthly mean temperature. And this is, but I believe if we reproduce our study using maximum, maybe the increase in the last 40 years is like 5 degrees, 7 degrees in maximum temperature. Talking with Bia Marimon, they have plots there. She told me last year they measure in the canopy high a temperature of 50 degrees Celsius. In a forest part, a fragment, it's inside some plot they are studying there. 50 degrees is, then I can say we are in emergency now. The southeast is to now, we can think in 2030 to complete zero deforestation for Amazon, but I defend we need to have some protocols for now to the southeast,
Mm-hmm. Thank you so much for that answer. There was so much in there, especially about how the different parts of the Amazon are suffering in different ways and how different parts of the Amazon are well past their tipping point, and the effects of deforestation, the effects of fire, the effects of temperature. You really packed so much in there. Your study, which was published in Nature, my colleague has dropped that in the chat, so hopefully listeners will click on that and read it if they haven't already, because it explains all of this in detail. But thank you for breaking it down for us here. But I think the thing that came across most prominently in your answer was exactly how you ended. It's the state of emergency, it's the urgency, it's that since the time you finished conducting the research of the study in 2018 until now, more damage has been done, and we maybe don't know exactly where we stand with the tipping point. So in terms of that, and in terms of what you told us about how different parts of the Amazon are in different states right now, in terms of protection and in terms of what needs to be done to counter this emergency, what do you recommend? What parts need to be prioritized for protection, and how do they need to be protected?
First, I would like to clarify, when I comment about these 2 million square is the regions that, about our study, where we made the vertical profiles in the Northeast and Southeast. When we integrate both this region, we observe these 2 million square, where until December 2018 was 27% deforested. Okay, when I comment about the deforestation in the whole in the Brazilian Amazon, I comment that in Brazil Amazon, 19 and 20, we have a 3% deforestation, and that is a mean of 1.5% deforestation per year. We know that to be a little bit higher than this, and then let's think, in 3 years, almost around 5% deforested. In 50 years, 17, and then in 3, 5%. This is extremely acceleration. We are in emergency. We need action now. We need to arrive in zero in 2030, but I expect we arrive in zero very, very soon, because Amazon will not survive if we delay, I can't say Amazon will not survive, but some parts of the Amazon, this west part and maybe the south west also, will not survive if we don't promote actions now. We need immediately moratorium deforestation in Amazon. This is a very important action we need to do now, and starting integrate, many parts of the society for this action, because everybody's interested. First, we have a law in Brazil that say 20% of forest can be deforested and 18 need to be preserved. In this region that I'm comment, there are regions that is 42% deforested in our study. Until December 2018, and the strongest deforestation is concentrated in these regions. How much this region is deforested by now? Some regions maybe is 50% deforested. And what we learn, deforestation represents direct carbon emissions, but also indirect, because of deforestation changes the climate conditions, mainly during dry season, promote a very stressful dry season that will promote more carbon emissions, promoting mortality, promoting more flammability of the forest, during the fire, because also people renew pasture using fire, and the fires come uncontrolled. This is happening in the whole Brazil, because Amazon interfere in the climate of the whole Brazil, in precipitation, in temperature, including the world, But the first impact is what is very near, and then we need to stop to think that we are making favor to the world. The first impacted for the deforestation in Amazon is the Brazilians. Agribusiness will be the first impacted, because without rain, without precipitation, agribusiness will be the first to have problems, with this. And then think, Amazon, that could be like a climate buffer, because it's absorbing CO2, is putting lots of water vapor to the atmosphere, and when do this help into reduce temperature, and I don't know how many more, effects in these feedbacks. And then I think it's nice to think in Amazon like a climate buffer. Mm-hmm. Deforesting Amazon, we are making the opposite. We are making Amazon accelerate the climate change, because we are sending more CO2 to the atmosphere, we are reducing precipitation and increasing temperature, then we are doing the opposite with the Amazon. how can we learn? How can be the limit? Okay, we have these 4 regions, and we observe in the west part that is around 11% deforested. You know, during dry season lost around 19-20% precipitation, but it don't make a difference. They continue, doing uptake. They compensate almost the whole human emissions. We are near neutral in the total balance there. And when we look, for example, EVI is how the forests are green, is almost no seasonality. It's like it's no stress for the forest during dry season. The reducing precipitation, the increasing temperature, still don't change the forest functions, because reduces 19%, 20%, but still is a high amount of precipitation. This is just proportional, but it's still, a very high amount of precipitation, enough for the forest to continue work without stress. Mm-hmm. But, in this west part, we are talking about 3-4 months, less than 50 milliliters of precipitation, accumulating in the months. This is very low. And then we needed to use these studies to think in the limit. And then you can make the question, because I make this to me many times, Luciana, if the northeast part is 37% deforested, why they are in better situation than southeast? I make this question many times to me. This is not easy to understand. Why? Why they are not in the worst situation? And I make a hypothesis, because the increase in temperature there is lower than in the southeast. When you look at this region, the region is around 700,000 kilometers square. When you look at the amount of water body, water surface with rivers, it's extremely high. I think it's interesting we calculate the water surface, but there is the Amazon's river, very large of water surface. The Tapajós River, in the Altar do Chão, that is below Santarém, the one part of the surface to another is 20 kilometer distance of water area, and then we have also Xingu River and the many flooded areas, lakes. We have lots of water, surface water bodies to evaporate. And that may be because you have two processes to recycling water: directly evaporation from rivers, lakes, and evapotranspiration from trees. Then maybe the forest there is less, or there the forest part is less than this 33% that is below. Maybe below is 50%, because I have much less water bodies than in the north. And then the evaporation maybe compensate, this extremely high deforestation there, and these make the temperature increase not so much than in the south part, the southeast part. This is my hypothesis, to explain this. And looking at west part, that is much less deforested, lose this 20% precipitation, I think that is because it go this recycling impact, and then are going less water to this part, you know.
Mm-hmm.
And okay, sorry, I started to go, and then if I didn't answer something, you make a question, please make the question again. Sorry.
No, it's okay. Thank you for explaining that. A couple things that stuck out to me is, first of all, that there are parts of the rainforest that are still neutral. So that is a slight glimmer of optimism in there. And what you were explaining about the different parts of the rainforest and the hypotheses that you're making actually leads into another question that I had for you, which is after this study that you concluded and published in July, what other questions do scientists such as yourself need to answer in order to figure out how to restore, how to protect, how to somehow reverse how close we are to this tipping point? What are the questions that we scientifically need answers to still?
First, if you ask me the southeast part arriving the tipping point, I answer, I don't know. You know, I include, I'm talking with Marina Irota, is the big person in tipping point now, you know, to and the other groups that are making plots studies in this region, and Adriana Esquivel that is focusing mortality, you know, and Luis Aragão, maybe Erika Beringer, you know, people that are studying. Let's put together the bottom-up studies with the top-down and observe everything we know now. If we can answer this question, if we have now, or if we need additional studies. This is one. Other, I want to repeat our study using this maximum temperature, because the maximum temperature is more related to the tree stress. And this will help you to compare with the people that study, you know, in the bottom up, they study more what is happening with the trees, you know, the mortality, how much it have, you know, this decomposition represent the respiration, this stress, you know, all this stuff. And also we have, we continue this study, the measurements. We have the measurements in 19, 18, this year, until next year, we have the projects running. We have funds from FAPESP, and we had some funds from European Community that is finishing now, and some funds from another colleague with finances from US that is helping and to go. And we need to observe, because when we remove fire emission from the other part of the flex, we say net biome exchange, that is all uptake, all photosynthesis, and all respiration and decomposition. When we look along these 9 years, we found an increase, you know, an important increase. And the very important increase was after the strong El Nino, 2015-16. I don't know if it is because it is strong El Nino promote much more stress or increasing mortality, or because the strongest deforestation happens in this place. We need to continue our measurements to answer this, you know, and observe how much increase, you know, the increase is linear or is exponential, and make the question, what is happening with the Northeast, that also is deforesting, you know, and they are also now in this, because the uptake in the Northeast represents only 20% of human emissions. It's very small, but still is some uptake. And then this is in the same situation or change, because we know that deforestation was accelerating in both sides. But in Southwest also is accelerating. And then in this part, we observe still neutral or is more emission. In fact, we are observing changing, in the regions. And it's very important we continue this study to observing the change that's happening. And I think the next step is integrating, the bottom-up study that understand better what's happening with the forest, with our study that just integrated all process. Because look, we measure CO2 in the air, we don't know where it come from this CO2. It was from fire, from deforestation, from decomposition or respiration. We don't know, but we know the resultant, all process. Imagine a parcel of air traveling, 90 days in the Amazon until arrive there. We'll see the resultant. And then if we put both these studies together, we can see there are something missing here, or some rates we use it to calculate the emission from deforestation, the emission from fire, the emission from decomposition. They are correct. They are, I believe, because we use just one number for the whole Amazon, I believe one solution is to study Amazon per region. Stop, apply, the factors, for one factor for the whole Amazon, for deforestation, for fire emission, for degradation. I think that the resultant, the better strategy is to divide. I remember, I know if you remember, in 2015, Roel Brinen was the first author in a big paper from Rainforest, publishing 3 decades of the rainforest. And we observed this mean for 30 years, but we also observed the decay in carbon uptake, in zinc, and increase in mortality. 2 years later, Oliver Phillips and Roel Brinen, they divide the same results in 5 regions. And then when you look what they published for these 5 regions, and I make this study because they put in tables, with all results per decade. I look at the tendency for this decade we study, from 2010 to 2020. In the southeast, it will be a source from forest. The tendency, include polynomial or linear, will be a source. And in the northeast, a very small uptake. It's very correlated. And then I think one solution is use this eco definition for regions. Ted Feldspat make this limitation by regions in one paper in 2012. I don't remember the paper, but I think one solution can be this.
Mm-hmm. Okay, thank you. And it's really interesting hearing you speak about all these different scientists and all the different research that's been done throughout the years. And it's just a testament to how complex this biome is and how much there is still yet to discover about how it works. But we are running out of time here. So I just want to end on one question, which is, We've discussed the urgency and the need for immediate action in the Amazon, which in part falls upon the countries that hold parts of the biome, and namely Brazil. But it also, as you said, the Amazon is accelerating climate change worldwide, which means it's all of our problem, it's all of our burden. What are some of the actions that people should be taking, whether that's the government of Brazil, whether that's a citizen here in Europe where I am? What are some of the actions that are needed to be done to help prevent the Amazon from reaching its tipping point?
We need first emergency make a moratorium for deforestation, and don't talk about illegal or illegal, doesn't matter, zero deforestation, and stop fire during the dry season. Because, I start to say zero fire, and then some people that communities, small agricultural activities need the fire. And then one solution is make these fires before this dry season, this very intense dry season, where the forests are also very dry and the fires can burn much more vegetation than is the objective. This is one. And then imagine it today, the deforestation is zero and the fire is also zero during dry season. Amazon could be an uptake, 130 million tons of carbon per year, first. And then second, if we do this, we start to give a condition to the forest to regrow, some restore. But this is not enough. In these regions where the deforestation are more concentrated, we need to have a program to reforest. But this program needed to be not only reforestation, because we needed to think people are deforested because they want opportunity to have economic activities. Then we needed to reforest, but thinking in a green economy, a sustainable economy, and then make these projects thinking in agroforestry, replant species that can bring, generate economy, thinking the fruits in the cities, and this say that we need a very big team in many, many, many areas, and bring all sectors of a population, We are talking about the agribusiness, the scientists, the technicians, ONGs, the justice, the legislation, who take care of the legislation, and how it's like a society agreement, because this is the future of the society, we need to integrate this, because the first sector that you will feel the consequences will be the agribusiness. They are starting to have a big economic problems with the reduction in precipitation. We needed to have this message arrive there. They need the preserved Amazon to continue the productivity in Brazilian agribusiness. We needed to think in bringing them together, to share what we are learning, to convince them that is better, bring science and economy together to construct a better future, because we are talking about the future of everybody. Sorry, to extend too much my message, sorry.
No need to apologize at all. I mean, I think it's a really important point what you're saying about the agro-business, and I've even heard the term agro-suicide be thrown around now, which means, they're destroying the very thing that
And
allowed.
I started to say we are planting drought,
Mm-hmm.
We
Mm-hmm.
are planting drought with the deforestation,
Mm-hmm.
uncontrollable fires,
Mm-hmm. Yeah, there's so much more I would love to discuss
Maybe
with you.
deserts,
Mm-hmm. Mm-hmm.
Yeah.
Absolutely. But thank you. I think you made some very important points about stopping fire before the dry season, doing it before the dry season, and then incorporating a sustainable economy into restoration and reforestation efforts is huge. And then lastly, just bringing all the sectors together, which is something that's talked about a lot and difficult to do, but needs to be done. So thank you for bringing those important solutions to the table here at the end. And Luciana, it's been such a pleasure to talk to you. It's been so great to pick your brain and hear about all of this incredible science that you're conducting. And to everyone who's listening, Luciana will also speak at GLF Amazonia, an event that's happening through my organization next week on the 21st through 23rd of September. So you can hear her again there. And to learn more about that, you can visit globallandscapesforum.org. And again, thank you so much for joining us. Thank you to everyone who listened in. And we will see you next time on GLF Live.
Oh, thank you so much in giving me the opportunity to share, our lesson. Oh, what we learn, what we learn in this study. That is really very important. And then I think it's very important to share all this, Thank you very much for this opportunity. And thank you, everybody. It was a pleasure to me.
Great. Thank you so much.
Como é que eu saio daqui?